Hi, everyone. Thank you for giving us the opportunity to present at the conference. My name is Adam, as Ryan said, and I'm joined by Jacob. We're consultants at Decision Lab UK, and we're going to be presenting a project that we've been working on for the past 10 months using Any Logistics and the extension editor. So we're going to focus purely on that, really. And we've used that to solve a range of problems for a client within the FMCG industry. So I'll get into that in a second. This is still an ongoing project, so I'll kind of share as much as we can, but there might be some things that we have to keep hidden just due to sensitive information and data and that sort of thing. So I'll start with a bit of an introduction. So as I briefly mentioned, the client that we were working with or still working with is in the fast-moving consumer goods industry. So they face a lot of challenges caused by their reactive approach to incoming demand and a lack of digital tools. So they don't have a good clarity on their data in terms of inputs and outputs. So that is not really helping with their decision making. So they're lacking in that sort of area. So that is ultimately hindering their growth and efficiency. So to help solve a lot of those problems, we implemented a supply chain modeling tool, which would allow them to improve their data analytics and therefore make more data-informed strategic decisions, as well as allowing the client to be able to test solutions or potential solutions in a risk-free environment within a tool like Any Logistics. So the result of incorporating Any Logistics into their workflow meant that they were able to then have a supply chain tool that would allow them to improve efficiency by automating the production of simulation and optimization models. And we coupled that with custom SQL outputs, which I'll talk about later, and Power BI dashboards to allow for a better understanding of their output data. So I'll go into sort of the purpose of this. So we did write a paper alongside the actual project. So like I said, they're FMCG industry. So managing a supply chain within that area is complex and challenging as it is. There's many issues with those supply chains, such as ensuring that products arrive at the right places at the right time. Also managing short shelf life inventory. So minimizing waste and making sure that we're not just wasting products and keeping them in inventory too long. As well as demand volatility. So constant changes throughout the seasons and so on. So these FMCG supply chains may have many bottlenecks and inefficiencies that make those issues a lot worse, which is what our client was finding. So using tools or supply chain management tools like Any Logistics can help identify where those issues are occurring and support the informed decision-making based on the data that you're getting out of these different models. That gives them more clarity over the entire process or entire network as a whole. So the paper we wrote alongside the project discusses how we actually integrated the tool into their workflow and how we used the extension editor within Any Logistics to customize the out-of-the-box features so that they were more bespoke to the client supply chain. So a bit of a client background or introduction before I go into the actual details on what we did. So essentially, we have this client, which is a UK-based manufacturer of baked goods. They distribute to retail stores across the entirety of the UK. But they have this strict 2-day expected lead time where products have to get from the bakeries to the retailers from the point that they were demanded at. So they have to ensure that they're not wasting products by storing it in the wrong places. They're using the right vehicles to get the right orders to the right places and so on. So they have to stick to that expected lead time. So in total, this client has 10 bakeries. Each one of those bakeries has an attached primary warehouse. There is one primary warehouse that is a standalone warehouse that doesn't have a bakery. But then we also have around 40 secondary warehouses, which are attached to the primary warehouses. And then the remaining secondary warehouses are just, again, standalone. So they just act as the end point or the distribution to the retailers. So this kind of setup that we have caused a lot of issues, mainly in the production planning, transportation and inventory management. Because we've got to get the products from the bakery to the primary warehouses and then through the secondary warehouses, it caused a lot of issues with how we actually move the products around, what type of vehicles we use, and how we plan the production to ensure that we still stick to that 2-day expected lead time. So the bakeries produce different types of products. So certain bakeries can only produce certain SKUs due to production restrictions and production lines, which meant that also added an extra complication when it came to cross-stocking and transportation of these products. So these products get produced at the bakeries. They have to go through a secondary warehouse before they can get to a retailer. So it meant that we always had to cross-stock. So because the production and distribution is nationwide, it meant that we had to make sure that we were using the optimal flows to ensure that we weren't wasting goods due to the 2-day shelf life. So this, like I said, caused a lot of issues, and we'll go into what those sort of issues were and how we actually solved them. So one of the main issues with the FMCG industry in general is the demand volatility. So because it's constantly changing, the supply chains are having to adapt to fulfill that demand. This is made harder when you have restrictions such as the 2-day lead time due to the goods that are being distributed being perishable. So this meant that the client needed to ensure that we always had enough vehicles to distribute these products, as well as having enough warehouse space to actually store these products in order to move them around efficiently. So that's where one of the issues was, or one of the main issues was found. The client identified these areas in which they were facing bottlenecks like that. And that was ultimately hindering their growth due to the lack of operational insight, like I briefly mentioned. Their data that they currently had was scattered across a range of different databases and systems. So any of the supply chain modeling they were currently doing was just done via Excel. They would have to pull in all of the data and try and find it, and then build those models within Excel. So that, as you can imagine, was quite difficult to do. And it's also harder to keep track of, and they can't really simulate it or optimize it as easy to identify and reduce those bottlenecks. So alongside this, they also had quite a reactive approach to demand, which made it harder to grow and reduce costs and remain flexible, which is something that they really need to do due to that demand volatility. So some of the business questions and challenges that this client in particular was facing, I've already mentioned, but we had to kind of work with them to actually figure out what they were. So they already knew what some were, but after they'd identified those sort of initial problems, we then decided to set up a series of workshops with them. So using those workshops, we were able to construct a series of user stories based on the problems that they'd already described. And we dragged in members from different teams, so production planning, distribution, warehousing, as well as any key stakeholders or management that were interested in the outcome as well. So we used those user stories mainly to aid in the production of these models. So we categorize them into specific business areas. So like I mentioned, production, warehousing, and so on. So using those user stories, we were able to identify the exact things that the model had to include and the exact features, as well as being able to set a list of functional requirements that the model would have to include or support in terms of runtime and so on. So when it came to choosing the software, it was a relatively easy choice for us because we've used any logistics before, but we kind of had to fit this into the client's needs. So after we understood the actual problems that the client was facing, we chose to use any logistics. And the main reason for that is that we were able to simulate their existing supply chain as well as their future supply chains, as well as optimize any potential network setups. So the client needed a tool that was able to design, analyze, and optimize all of these things within their supply chain network, but ideally it had to be within one tool. So that's why we used any logistics, because it allowed us to do all three of those. So that was kind of the answer to many of their questions already. But then they kind of realized that there was extra things to any logistics that they didn't necessarily know about. So we'd kind of focused just on simulation, but they didn't really look into using the greenfield analysis to do center of gravities or brownfield analysis and so on. So when they found that obviously then decided to sort of swayed their decision even more to any logistics. So on top of the actual work that we're going to talk about, there was a load of other stuff as well in terms of the center of gravity and network optimization. So I'll talk about the solution next. So like I mentioned, we kind of solved most of the problems with the out-of-the-box features of any logistics, but many of the problems that the client was facing required bespoke features. So like I said, although it answered most of them, a lot of the functionality we had to actually alter to fit their supply chain because they had so many different complexities and intricacies within that network. We couldn't necessarily solve all of them with just the out-of-the-box user interface. So another benefit of any logistics was that we could use it to utilize the extension editor. So for anyone that's not familiar, it's using the AnyLogic engine under the hood. So we have this simulation editor that we can use to alter the entities within the network. So things like the distribution centers, the factories, customers, and suppliers. And we can edit the process flow for each of those entities. So we use that to basically build in the custom features that we couldn't get from the out-of-the-box solution. So some of the aspects that we extended for this client included resource utilization, sourcing logic, but I'll go into the rest in a second. So there was quite a lot to this. So the majority of the work we did for this project was all done within the extension editor, as well as using the default UI. So it was quite a difficult and iterative process because this extension editor was new to us. We'd never used it before. We had to make sure that worked alongside the default out-of-the-box features as well. So we kind of had to make sure that we weren't just adding in things that were completely breaking the standard functionality. So as I mentioned briefly, we had a bunch of different features that we added in for this client. So these were completely bespoke features. So we added in things like resource utilization, production and bakery logic, SQL database outputs, product sourcing, and cross-stocking. So a lot of these things that you see on the screen are already in any logistics. So we are able to do the production and bakery logic. We're able to import and output data from SQL databases. But like I mentioned, because this client had very specific needs and it was very bespoke, a lot of the things like the sourcing logic, we had to come up with custom algorithms that weren't necessarily in the out-of-the-box tool. So we'll go into those now. So in terms of resource utilization, this is quite an important thing for the client. They needed a better understanding of their utilization of resources within their warehouses. So they weren't necessarily concerned with the bakeries themselves. It was more just the warehouses at this point. So they needed to understand how the number of staff members impacted the loading or unloading time of the vehicles that were coming into these warehouses. So this was a feature that we customized with inside the DC entity of the extension editor. And we were essentially able to create a set of resource pools that represented these staff members. And then we used them within a customized process flow for that distribution center. So the customized process flow also included a modified queuing process. So slightly different from the standard any logistics one. And it utilized loading and unloading bays as another resource. So that way the user could use input the number of loading and unloading bays at a warehouse, as well as being able to change the number of staff they have for different tasks and so on. So we used all of that logic that we built in to essentially utilize the resources in a better way than what we were originally doing. So essentially we customized the process so that depending on the number of staff members, the loading and unloading process would be slower or quicker, which was something that we weren't able to just get out of the standard option. So this was quite an important thing for them because the time it took to unload and load products onto vehicles and into the warehouse had a massive impact on how much space they actually had in that warehouse at any point in time. So we needed to understand where there was space in warehouses so that we knew where we could move products to. So essentially to show that, we output data related to all of these different things that we've just added for resource utilization. So we output custom data for the amount of time spent queuing for a bay, the loading and unloading time for these tasks, and so on. And we'll talk about the actual SQL outputs in a second and go into a little bit more detail on that. So the production and bakery logic was also something that we had to customize. So we could use the standard functionality where we just have the production time per unit and certain bakeries produce certain products. But the issue we had with that was that they have very strict restrictions and constraints on production capacity. So they had essentially a set of bakeries, and each one of those bakeries had a different amount of production lines within that facility. So the number of production lines they had basically represented the number of, the production capacity for that bakery. So if they had one production line, that is 24 hours of production capacity. If they had two, 48 hours, and so on. So this was quite important when it came to producing SKUs and producing production plans, because they needed to ensure that they had enough production capacity in that day to be able to produce the products and still meet the demand. So each product for this network had its own production time per unit. However, due to the constraints, like I mentioned, in the real world, these products have to be essentially categorized by type. So based on the tins they're produced in on the production line. And using those tin types, we're able to define the production lines that can produce certain products. So only certain production lines could produce certain SKUs. And we decided the easiest way to do this was to essentially split the bakeries into multiple objects within the network. So you would have one that represents one tin type, one that represents another, and essentially they would be on top of each other. So we did that just to make it easier to handle the ability of what the bakery can produce. But we also still had that production line capacity within the extension editor. So every bakery still had its own production lines. And we use those calculations to essentially read in, we use those production lines to essentially read in the data for production time per unit. And then we created custom calculations to work out how much production capacity we would have left after we produce a specific order. So that way we were able to use the information on the order coming in and check if we could actually produce it within that day. Therefore, if we could, we would know we'd still be able to get it to the customer within that expected 2 days lead time. So overall, this essentially allowed us to build custom production restrictions, which again included a daily production limit, a maximum queue length determining how long orders have to wait before they can be produced, as well as inventory level checks to ensure that we weren't producing too much and sending it into a warehouse that's already full, because that would cause a bottleneck. So I mentioned briefly that we use custom SQL outputs. So by default, any logistics supplies you with an import and export for data. So you can send data to an external database already. But because we'd customized so much of the logic within the actual extension editor, we had to find another way to output the data. So we were capturing information on stuff that shouldn't really be done. So we weren't using the sort of standard data that you get out of the charts in the Any Logistics UI. So the client essentially required a quick, simple way to get that data out of the model or out of Any Logistics and then display it in a dashboard. So we used a library called JDBC. So this was done purely through Java, and that allowed us to essentially connect to their database from inside the extension editor and then directly write to that database. So at the end of every model run, the data that we collected within the extension editor would get output to the SQL database directly. And that just meant that we didn't have to stop the model and output the data every time. And it also allowed us to output the custom data that we'd been collecting through the extension editor. So after we'd output that data, it automatically got sent to a Power BI dashboard where we visualized all of these different statistics, which I'll show you in a second. And that was allowed the client to be able to analyze the data outside of Any Logistics, as well as utilize Any Logistics for the actual simulation and optimization runs. So I'm going to pass over to Jacob now, who's going to go through the product sourcing logic.
Yes, so one of the big issues we sort of faced during this project was figuring out for each customer and then for each warehouse as well what the best place to source from was. And that actually initially seemed like a simple solution, but as we went on, it got a bit more difficult. So one of the big things was sort of whenever a order was passed to a DC, it would initially just create a new order and then treat it as that DC was requesting the products. But this caused an issue where it wasn't really preserving the initial knowledge of where the order came from. But we added in like a subclass of order that was just called My Order, which allowed whenever a new order was created, it would pass along the knowledge of where the order originally came from. And similarly, we did something like that with production order to make sure that whatever products were produced weren't just going into the inventory and then were like free for whatever order to take them, but they were produced specifically to go to another order, so they would know who would get the products when they were finished. So like whenever a shipment arrives at a primary, it would then pass the products back to the correct order that was waiting in that primary. And then when we were sort of thinking about the sourcing paths, again, we initially started with the closest source path, which was sort of the out-of-the-box result. But we sort of noticed they weren't creating like the most optimal sourcing paths. So as we can sort of see in the diagram on the right, obviously the quickest solution you can see from the customer would be to go to primary D and then bakery A. But because sort of when the sourcing actually takes place, customer A would only look at primary A and primary D. It would just see, well, primary A is closer, I'll source from there, and only then would primary A start looking at primary B, primary C, primary D, and then over to bakery A, which wasn't really realistic. In reality, they would be able to see like the full network, and they would know, like in real life, well, if we were to go from bakery A to primary D to the customer, then it would be a lot quicker. So in order to do that, we decided to use Dijkstra's algorithm, which is like probably the most well-known shortest path algorithm. And we did this from each customer to each bakery. We would determine what the shortest path is. So both by distance and also by which warehouses it would stop at along the way. And rather than at each primary warehouse checking, well, where should I go next? It would already have that knowledge. So it would just go to the next one along the sourcing path. But again, after introducing this, it was producing results that were better. But these still weren't quite what our clients were looking for. And this mainly came in the form of two SQL inputs. So some primaries are designed for cross-docking. So they might have one primary that is like in the middle of the UK, and that would be like have a capacity of 40,000, for example. And that would be, well, any orders that are going from the south of the UK to the north or vice versa would go through that primary because that's the one that's designed. Whereas there might be some warehouses that are quite small and they might be only exist to ship to like a small area. So what we added in was, in the SQL inputs, there was a list of preferred paths. So if there was a case where there was like a specific path that our client would want the order to take, then it would follow that path rather than just picking the shortest path. And then also a list of non-cross-dock primaries, which are sort of primaries that we would only want to be used if it was the only option. So again, these are primaries where they might exist only to reach like a certain customer that can't be reached by any other primary. And that would be the only case they were ever used. And we sort of did this by, in Dijkstra's algorithm, if it ever used that primary, it would add on like an arbitrarily large value to the distance. So like the only way it would ever be selected would be if there was no other option.
So I'll go into some of the results next. So like I mentioned, because it's currently an ongoing project, we can't really show all of the outputs that we have. But the main idea of the project was to essentially help the client overhaul their workflow and incorporate a supply chain modeling tool like Any Logistics. So that would allow them to have better insight into their network. So as I mentioned before, they were using Excel to manage everything. And they had data scattered all over the place. So this gave them a sort of central point that would pull all of that data in and then allow them to run these models. So we could run simulations and network optimizations to get these outputs and then make the data informed decisions off the back of it. But we also obviously included these bespoke features that integrate with the sort of standard functionality of Any Logistics. So they still had all of the default capabilities, but they then had the extra stuff that we'd added on top of it. So we made sure that we combined it all to give them a more granular sort of level in terms of the outputs. So one of the main outcomes we got from the project was that the client was provided with a set of Power BI dashboards, like I mentioned. So we essentially extracted that data from the extension editor. So everything we'd captured in terms of inventory levels, staff utilization, queuing times, and so on. And we output that data on an hourly basis. I think we made it even more granular at one point and dropped that down to a 10-minute basis. So if they wanted to view the inventory level every 10 minutes, they could do that. And that would be displayed on charts like you see at the top of the screen there. So That way, they were able to identify which warehouses had space. So each warehouse would have its own graph, and they could look at where the different space, what the actual inventory capacity was at these different sites, understand where they had space to be able to move products, and that way they could essentially move products around without hitting the capacity as they were before. So that is one of the main bottlenecks that they've already identified, is that they were currently storing products in an inefficient way, and they were doing it based on a gut feel. So this dashboard is now giving them that data to actually make the decisions off the back of something, and not just kind of guessing where they think stuff should be stored. So some final thoughts. Like I mentioned already, the additional features were added to the simulation model of any logistics to essentially extend the default functionality and tailor it more to the client's requirements. So we still kept the default functionality, like I mentioned, but also added some extra stuff on top of it. We created SQL outputs and Power BI dashboards, so it gave us more data granularity and visualization. So we can still use the standard charts that you get within any logistics for certain aspects. So for example, if they just want to run a quick simulation, they can still see that information there. But then they've also got the extra stuff that we've outputted from the extension editor visualized within this Power BI dashboard. So that, again, allows them to make better decisions based on the actual data they're getting out of it. We integrated this with their existing IT infrastructure. So like I mentioned before, because they were using Excel, they didn't really have a central point to pull all of the data into. So they were kind of grabbing data as and when they needed it, putting it into Excel, and then figuring it out from there. So what we essentially did is created a standard sort of central database that pulled all of this information from systems like SAP, and then pulled that into any logistics, and then outputted it to the same sort of place. So that gave us a more central location to actually keep all of this information and data. So that allowed for a better understanding of the supply chain data. And then it made it a lot easier to identify where the inefficiencies or bottlenecks were within the network, which was a lot harder to do before because a lot of the data was poor quality. And then because we've integrated this into a wider digital transformation, they now have more clarity over the entire network as a whole, and hopefully will improve their resiliency as a supply chain. So thank you for everyone who's joined and listened. We'll stick around for a couple of minutes and answer any questions if there are any. I'll just stop sharing.
Yeah, Jacob, thanks very much. There are a couple of questions there. Can you see them in the chat?
Yeah. So there's a question saying, can you give an example for building a custom feature? So we don't have any examples right now. It might be something that we're able to share in the future, but because it's still ongoing, not too sure on that yet. So hopefully, eventually, we'll be able to actually give more detail on that. I think there was one about Dijkstra's algorithm in Java. So it's probably for you, Jacob.
Yes. So how we were able to implement that was because we already sort of had it in the form of a network. So each customer, each bakery, and each primary would have sort of knowledge of who its sources were. We could sort of set that up as a network. So we started with the customers, and they would know who they could source from. So in a sense, we knew that was the path. So it would look at each of the places it could source from, and then it would note that down as the path. So if customer A could source from primary A, we'd know that it would first go to A, and then it would traverse that until it reached the bakery. So by the time it got to the bakery, it might have like path, it might go to primary A, then primary D, and then to bakery C or something like that. And as it went, it would use because we had the distance matrix sort of in the table, it would know the distance from each location to each location it could source from. We could use that to determine the distance. So as we went along, we could update what the shortest distance was at that point. And then if necessary, we could update the route to reflect this shortest distance. And yeah, that's how we did it.
Great answer. Thanks very much, Jacob. Okay, so that's all the time that we have for you, unfortunately, but there are a couple of questions still there in the chat. If you don't mind answering these questions later, that would be great for our viewers.
Sure.
So Adam, Jacob, thanks very much.
Thank you very much.
Yep. Thank you.
Bye.